Hey there, viewers. Welcome to space. If you like highly detailed imagery of the sun and the most comprehensive space weather in the known universe, you've come to the right place. The Smash News Network least busted name of news. Thanks to each and every one of you spaced out viewers. And congratulations on realizing the channel exists. These are 24-hour videos from SDO. You're watching the collapse and flaring of the plasma that made up the Brian Keating filament. So right there, you'll see some CME activity happening, as well as part of that filament collapsing back down toward the chromosphere. Here's a slightly more zoomed out view. These are 24-hour videos from the SDO. The wavelength is 171 angstroms, which is part of the extreme ultraviolet spectrum. And the chemical species that you're looking at here are ionized iron. So there's the full disk view, the past 24 hours. We do have at least one more new sunspot that is up here in the northeastern limb. Besides that, mostly stable. Flaring has been kind of low. We'll get through lots of information. So make sure you press like, subscribe, and share. Tell your friends and foes about the Smash News Network least busted name in news. Again, we are frankly surprised that you've found the channel. Congratulations on accomplishing that feat. Tell your friends and foes about us, and promote us on your social media if you have not yet unplugged and or thrown your computer out the window. Check out the links below the video. You may find the link to the Redbubble shop. We've recently put up 4 new merch items. So check those out again below the video. You'll find in the description, you'll find the link to our Redbubble shop in order of best selling. Today's featured product is one of our oldest pieces of merch. So despite new pieces of merch, people still like the old merch as well. And congratulations on surviving a global scamdemic so far. You're doing a fine job, and congratulations on not being dead. To make things even more, is that too inflammatory? I apologize. So check out the Smasher Price, My First Scamdemic graphics. You find that in all kinds of different designs there. Again, that's one of our first merch items ever. Of course, we released that one back in 2020 in response to the, shall we say, less than beneficial and appropriate response by mankind to, well, you know what? It's one of those words that we don't say on the channel. You can also find links to the merch shop at the homepage at smashomash.com. So check that out. That's the official homepage of the Smash News Network least busted name in news. Consider becoming a member of the Smash team if you want to support the channel. There's a silver, a gold annual paid up, and even a bronze level there over at the Smash Team site. Yes, smashomash.com/Smash Team. And let's move on. And let me just check the life of the stream here, as we are having some technical difficulties at the Smash News Network least busted name in news. Not necessarily our fault. Anyway, these are also 24-hour videos. And we've got a massive number of solar filaments at the moment. So, huge number of solar filaments in the Earth-facing portion of the solar disk. And let's take a look at some of those. We made a video just all about this filament down here, this huge prominence that is partially still intact, part of it relocated, down closer to the south heliographic polar region. Here's where we see a new sunspot rising once again, and possibly more sunspots behind that, as we see a lot of material suspended out there by magnetic fields, huge plasma filaments all over the Earth-facing portion of the solar disk. Likelihood of coronal mass ejections still at nearly 100%. Here's your northwestern limb also, just north of where you saw that filamentary collapse behavior. And let's move to the highly active southwestern limb. Looks like some more material getting ready to disperse here. That's the Nikki Haley filament there. The southern part of that looks like it is getting unstable. And how about an extreme close-up of that Brian Keating filament collapse? Yeah, if you want to name filaments after living people, just head to our Twitter and follow the hashtag #NameThatFilament. Also, the hashtag space weather is a good call, as we are part of the space weather Twitterverse. Yowzers. That is some good imagery. That's 304 plus 193 angstroms, by the way, ionized helium in 304 angstroms, and ionized iron in 193 angstroms. Dag, that is some good stuff. So here's I don't know what's going on with the browse data lately. The browse data's been acting funky lately, folks. It's been creating a bunch of flashing, annoying images. I don't know what's up with it. Here's the SDO intensity gram for yesterday plus today. Again, most of those sunspots highly stable here. Not a lot of umbral evolution at all. A little bit of growth in this sunspot group here, but besides that, things quite consistent. Again, there is at least one new sunspot that just rose in the northeast. There's yesterday plus today colorized magnetogram. For your viewing pleasure. Number 1, I order you to refrain from taking a number 2 in your pants. Let's see what's going on with volcanic activity here real quick. We've been showing a volcanic uptick here on a worldwide basis for the past few days. At the moment, Stromboli now producing not only, well, it's ended its effusive eruption, but continued on with the Strombolian eruption, not to be confused with the Calzonian eruptions. Also, Shiveluch on Kamchatka continues to explode there, producing a 13,000-foot plume of volcanic ash, flight level 130 over Kamchatka from Shiveluch. Sakurajima also producing some... what the hell? What is going on today, folks? Forces are aligning against me. Sakurajima producing a 10,000-foot volcanic plume of ash. That's a flight level 100. That's an uptick at Sakurajima, I believe. Subanosejima, flight level 040, 4,000-foot ash plume. In central Java, Merapi here, producing a large glowing avalanche known as a pyroclastic flow. Don't be in the way of one of those. That'll make for a bad day. Also, massive ash plumes affected much of the southern flank and caused panic in some villages. Popocatépetl exploding in central Mexico, flight level 220. Santiaguito in Guatemala, they're extruding some new real estate. Folks, I apologize that I am unable to operate a computer or speak the English language today. Don't worry, I'll get back to it. Santiaguito, they're producing some water vapor emissions and gas emissions and a sticky lava flow. Fuego in Guatemala exploding, flight level 150. That's a 15,000-foot ash plume. 19,000-foot ash plume over Colombia from Nevado del Ruiz. Not sure about Sangay and Sabancaya. Don't assume that they're not erupting, and let's move to seismicity. There's the past 90 days, and we've got a lot of earthquakes here in the past 24 hours. No major ones. Keep in mind, some of those could be foreshocks, folks. Some of those could be foreshocks. Any earthquake can be a foreshock, even if it's a huge one. So keep that in mind. We're going to report on those that are over a 5 magnitude. So lots of quakes here, especially around the Pacific Rim. A couple there adjacent to the Mediterranean Sea also. Also the Adriatic. Anyway, we've got a 5.0 at Colombia. That is the oldest 5+ magnitude quake to occur in the past 24 hours. That occurred at 2047 Universal Time yesterday on March 10th. So only a couple here over a 5 magnitude, like this 5.2 at the Izu Islands there near Japan. That was at 0:16 this morning. A 5.3 struck Indonesia a few hours later at 4:03 Universal Time this morning. And that's it. It's time to get back to space. So now we've brought up the, this is 1,700 angstroms plus 171. That'll show you the surface at the chromosphere. That's the 1700 angstroms. And then the lower corona is the 1700 angstrom, is the 171 angstroms. Those are some great wavelengths to view sunspots and the magnetic fields associated with them. Now we've swapped out 1700 angstroms for 131 angstroms. This is good at showing the lower corona as well as solar flaring activity. 131 angstroms being the hottest wavelength covered by the SDO AIA device. Those are both species of ionized iron. And here we've swapped out the 131 angstroms for 211 angstroms. This is great at showing the extended corona and coronal holes. Also, filaments are very visible in these wavelengths. Huge filament up here. This one is quite spectacularly large. Also, some filaments hanging around at the north heliographic pole. Some significant plasma migration happening over here. You see a coronal hole open up and then close back up again right after that flare and CME event happened. We'll show you where that's directed a little bit later in the video. Let's blast through some solar data. So the 10.7 centimeter radial flux has dropped all the way down to 171 solar flux units. There is the 1-year graph of that. The black line is the radial flux. The red line is the sunspot number. Pink line is the 30-day smooth Wolf number. That's based on a sunspot number over a 30-day average. And then the blue line at the bottom is the AP, the Potsdam AP index. That's simply an average of Earth's geomagnetism. Next, looking at our space weather enthusiast dashboard here, no space weather storms forecasted. Things are pretty calm in between the sun and the Earth at the moment. We don't believe there are any Earth-directed CMEs. However, there is a coronal hole high-speed stream on the way. Here's the past 4 hours of Earth's magnetic moment from space. You're looking at about 12 Earth diameters here, and the space weather modeling framework is modeling in this imagery magnetohydrodynamic pressure, the units of which are nanopascals. Again, things calm here in the past 4 hours. Earth's magnetic moment from the ground also pretty chill. That's our ground magnetic perturbations map. Geospace delta B means changes to Earth's B field. KP index currently at 1, so geomagnetically calm conditions, just like yesterday when we made our video. It was a KP1 yesterday as well, I think. The KP index is a measurement of global geomagnetism. And here is our real-time solar wind coming next. And this diagram just shows Lagrangian points. So just to give you some facts here, Lagrangian point 2, that's where the James Webb Space Telescope is located. Lagrangian point 1 is where the ACE and Discover spacecraft are measuring the real-time solar wind. Also, the LASCO C2 and C3 are out there at Lagrangian point 1. Those are the coronagraphs that we'll show later in the video when we cover coronal mass ejections. Current conditions for the real-time solar wind are about 450 kilometers per second for the solar wind velocity, solar wind speed. That is the solar wind speed, that is. Solar wind density here about 2.5 protons per cubic centimeter. And let's move into magnetic data. So there are the geosynchronous near equatorial orbiting GOES 16 and GOES 18's magnetometers. Nothing too special going on there. And let's take a look at some polarimeter data. There's our top view ecliptic plane field plot showing the polarity of the heliospheric current sheet. So Earth is solidly in a North Pole current sheet. No changes expected for that anytime soon. Keep in mind the magnetic environment can suddenly change. Let's take a look at the line of sight field plot next. There's the sun's B field depicted in blue, North Polar field in green, South Polar field in red, which brings us to coronal holes. We've got some well-defined North Pole-oriented coronal holes here currently in the Earth-facing portion of the solar disk. That's our line-of-sight coronal hole field plot. It's depicting March 7th through March 11th. And let's take a look at 211 angstroms all by itself from SDO. So there you go. This is a trans-equatorial North Pole-oriented coronal hole. We can expect a high-speed coronal hole wind stream from that in about 3.5 days. It probably won't be real extreme because that's not a very well-defined coronal hole. However, we'll have to monitor that, and we'll let you know what's going on with some forecasting as it gets a little bit closer to arrival time. Next, we'll move to sunspots. Since there's always plenty of activity to cover, even at solar minimum. And currently, we're not at solar minimum or solar maximum. There are your sunspots, and as many as 14, I think, showing up here. As many as 13 showing up there on the solar flare probability monitor. Again, there will be at least one new named sunspot group up here. Maybe as many as like 3 by the end of the day today, but we're expecting at least one more group to get named. That'll be 3253. And let's take a look at sunspots on a 24-hour scale. There is the past 24 hours. Lots of sunspots, many of which are larger than the Earth. Not a lot of activity, though. So a little bit of growth down there in the southeast, but besides that, things mostly stable here. Again, maybe a couple of new sunspot groups to be named in the northeast. 3253, 3254. I'm expecting 2 new named sunspot groups up there, so we should have a little uptick in the sunspot number, maybe a little uptick in the radio flux as well. Here we've included the 94 angstroms wavelength to show you the flare players. And there's the full disk view. As far as energetic particles go, we ain't got none. The ghost proton flux is flatlined. No relativistic particles produced lately, and solar flaring now has dropped down below a C-class background level. So now the background output of the closest star in terms of X-ray output is just at a high B level now. So the current conditions are like a B 8.6 X-ray output. So a slow ramping down here over the past week plus. So lots of sunspots here, just not a lot of flaring activity. And let's take a look at 94 angstroms. That is yesterday plus today. Give that a minute to initialize here. And I'll just play tiddlywinks in the meantime and cross my fingers and hope for the best. Something that we do regularly at the Smash News Network, least busted name in news. And by the way, if you're worried about the end of civilization or the end of the world caused by nature or something like that, I'm here to tell you that our finest days lie ahead. So, just still waiting on that SDO browse data. That's okay, SDO website, we'll wait. I'll just press submit again. And, okay. And I'm about to abandon this section of the video. Yeah. All right. Well, let's just move on here since the SDO browse data refuses to return any data. I'm gonna try one more time. I'm gonna press refresh, put the dates back in, and press submit. Oh, there we go. How about that? Isn't that exceptional? All right, there you go. There's yesterday plus today in 94 angstroms wavelength. And how about a little zoom in? Cool thing about the SDO browse data, once again, folks, if you didn't see yesterday's video, the browse data is pretty cool because it allows you to press pause and then show certain features. So we're going to pause it right there and show you there's that Brian Keating filament collapse and coronal mass ejection happening in the southwestern limb over there. Let's slow it way down. So at this point, the magnetic fields changed drastically. Some of the plasma was flung out into space. Other plasma succumbed to gravity and rushed back down toward the chromosphere, where it emitted some X-rays. Anyway, moving on to a star chart. So we like our viewers to be oriented here at the Smash News Network, least busted name in news. So we like to show a star chart daily as we're interested in what's going on overhead, and we encourage you to look up. Although right now, if you look up over Lehigh Valley, Pennsylvania, it's very cloudy. Saturn and Mars are up there, also the Sun, Jupiter, and Venus, as the Moon is just setting on the southwestern horizon. Next, we'll do a solar system forecast, as we're wont to do daily. We like people to know where things are and not to be confused about things like cosmology and astrophysics. This is a bit of astrographics, meaning the locations of objects in space. Let's do a 1-week forecast. Here's where things will be in a week on the 18th. Earth is on a lonely side of the solar system at the moment. No other planets over here, especially no gas giants. Continuing on to our coronagraphs. Speaking of gas giants, the sun is giant, and it's got some gas in its atmosphere. What do you think the solid core of the sun is made out of? Anybody? Leave us a comment. Let us know what you think the solid core of the sun is made from. Do you think it's made of plastic? Perhaps maybe it's made of gold, folks. Maybe it's made of carbon fiber. Let us know what you think. Anyway, this is yesterday's coronagraphs. 2 CMEs there coming out of the south and west. Here are today's coronagraphs. Let's take a look at Stereo A plus Soho Lasco C3. Stereo A is located right out here, just a few degrees east of the Earth at the moment. And there are those spectacular CMEs. Also Mercury showing up there on the coronagraph imagery. We'll let those play through. Keep in mind they are not synced and they are not the same time and dates, so pay attention to the time and date stamps at the bottom. There you can see part of the Brian Keating filament there making its way out at the end of the day yesterday. Again, that filamentary collapse and CME happened starting at about 1600 Universal Time yesterday on March 10th. And no, those are not Earth-directed coronal mass ejections. Unfortunately, we generally always hope that they are earthly directed, as we want to see more aurora here in Pennsylvania. So here are our 24-hour videos featuring, that's SDO 193 angstroms, Soho Lasco C2 and C3, and of course Mercury in your lower right. We've zoomed in a little bit closer, as that's a great light show once again. And how about even a little bit closer there? You can see the way the plasma becomes a lot more diffuse as it starts to exit the corona, getting farther and farther away from sun's gravity and attempting to reach static equilibrium. Yeah, gas. It spreads out to try to fill the empty space of space, which of course we know it's not completely empty. However, it's empty in comparison to the amount of air you're currently breathing while watching this video. So continuing on to our filamentary imagery, and again, crazy huge filaments. So this prominence is still hanging out up here. We've also got this massive upside down J-shaped filament up here. The Brian Keating filament is still partially intact. You can see part of it still here, trailing the Nikki Haley filament, which has actually grown, and I think part of that is becoming unstable. So again, likelihood of coronal mass ejections remains at nearly 100%. We would like to see these filaments named. So this one here especially, also perhaps this prominence down here, Those would be some great filaments to name. And if you want to name filaments after living people, once again, make sure you join us over on Twitter. So we've still only got 390 followers. I mean, we can't even get to 400 followers on Twitter. It's quite pathetic. I mean, we've had a Twitter account since 2019 and 19.3 thousand tweets, daily original content, the most detailed space weather and solar imagery you'll find anywhere in the world, and 390 followers. So name that filament. And make sure you follow the hashtag Space Weather also on Twitter. If you don't have an account, why not get one? And if you've unplugged from all social media, we don't blame you. It is very pathetic. So taking one more close look here at this filamentary collapse. This is the 171 angstroms wavelength once again. And let's zoom in all the way. There you go. There is some eye candy for you. And we're almost to our bonus feature segment, the bridge between space weather and meteorology. Don't get them confused, folks. There is a reason why we call it space weather. Maybe one day they'll all be the same. At the moment, they are indeed not. Yes, of course, space weather affects Earth weather. However, it might not be in obvious ways based on the instruments that you're looking at, as most people are interested in what's going on in the troposphere, and space weather's not doing very much to the troposphere, at least not in a direct fashion. Anyway, that's the past couple of hours there from the AGOS 16 SUVI 304 angstroms wavelength. Name that prominence and name that filament. That's your homework until tomorrow. We'll see you on Twitter and the rest of the interwebs. Here come our bonus features segment. This is the satellite's charging hazard, which is pretty smooth at the moment. No charging hazards showing up on the satellite's community dashboard. And there is the electron flux for the past 3 days. Seeing a little dip here in electron flux. Let's see what the forecast model looks like. There are the green boxes of the forecast. The yellow diamonds are the observation. No argument there. That's the NOAA forecast for the relativistic electrons, and there's the 1-year graph to put it in context. You'll see that dip down a little bit today. That's not been updated yet. Oh, there we go. I pressed refresh, and now you've seen it update. There you go. All right, perfect. Continuing on to the ionosphere, we've got some massive high-frequency anomalies, especially around the South Pole, happening in the ionosphere. So this is the F-layer, one slice, the upper thermosphere, the bridge between Earth and space. And check out the massive high-frequency anomalies, especially in the southern hemisphere, but really spreading globally here. So this is an interesting day for our ionosphere data. We show it daily on the channel. If you're interested in what was happening last year at this time, well, we've got our space weather videos in a playlist. So you can go back and see what was going on last year at this time if you like. Space weather certainly does affect the ionosphere. So anyway, huge high-frequency anomalies happening, especially you're going to see a lot of blue on the anomalygram when we show it. And look at all the blue. That's anomaly in megahertz from a 30-day median. Blue means high-frequency anomaly. So lots of high-frequency anomalies happening there around the South Pole, southern Oceania, the southern Indian Ocean, southern Atlantic Ocean, southern Pacific Ocean, southern ocean around Antarctica, and even some of the northern hemisphere. So that's the story of the day for the ionosphere. Those are the most high-frequency anomalies we've ever covered on the channel. I mean, I can tell just by looking at it. Feel free to go back and look at our previous videos. You won't find more high-frequency anomalies than that before. So that's probably a predecessor to a sudden stratospheric heating event, by the way. And let me just share with you a fun fact about why we're not seeing a grand solar minimum. So one of the great features of space weather is that we monitor things like the thermosphere. So not only was cosmic ray flux higher at the transition between solar cycle 23 and solar cycle 24, cosmic ray flux was higher then. Yeah, it just was. The thermosphere was also colder then at the transition between solar cycle 23 and 24. Sunspots were lower, and the 10.7 centimeter radial flux was lower. That's a lot of features indicating that, well, solar cycle 25 is a vastly stronger cycle than solar cycle 24. And it looks like it's going to be an even stronger solar cycle than 23. So stay tuned to the channel for that. There's the latest image, 1300 universal time ionogram and 1300 universal time anomalygram. We also want to show the total electron content, as this does give some additional insight into what's going on in places like the inner Van Allen belt, the inner portion of the outer Van Allen belt, the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the thermosphere, the ionosphere. So this is the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. It will show you the most likely places for GPS errors. And thanks for leaving comments, Twitch viewers. We will not be visiting any links that you're posting. So, thanks for posting the links. We'll check it out, but it's not endorsed in any way. I have no idea what it is, and I'm incapable of checking it while doing the live stream. So that's the most likely places for GPS errors. If you're expecting GPS errors while navigating, perhaps turn on Wi-Fi location accuracy. That might help you out. And we'll close out the space weather portion of the video by looking at the latest intensitygram and latest colorized magnetogram. So we want to look at these sunspots that are rising over here especially. So there's at least one more group there. I think we're going to have 2 or 3 more great named groups. So this group up here doesn't have a name yet, I don't think. This group here definitely doesn't have a name yet. Those will probably get named today. They are fairly simple sunspots. This one up here is beta gamma class. It might even be beta gamma delta class already. It's looked like it's capable of producing some flares already, so that's something to keep an eye on. And when I say ion, well, pardon the pun. This group over here looks like it's only alpha class. Nope, I'm going to say that's beta gamma class also. This group down here, that's alpha class. Anyway, let's do the full disk rock back here, as we haven't had a lot of umbral evolution or anything over the past 24. I think probably the most likely spot for major flares is still this group down here. And let's continue on to meteorology. So quick reminder, folks, the equinox is on March 20th at 5:24 and 20 seconds Lehigh Valley time. So we're actually not located in Allentown. We are located in Lehigh Valley, though. We'll be about that vague. We will be streaming live on YouTube at that moment. We'll probably start the live stream about 5 p.m. on March 20th, as it is a normal feature of the channel to stream at the exact moment of equinoxes, as that is certainly, you could say it's a space weather event. It affects the radiative transfer of energy from the sun to the earth. If you want to support the channel, consider becoming a member of the Smash Team at smashomash.com/SmashTeam. Join at the gold or silver level, especially if you want to support the channel. There's also a bronze level that doesn't cost you anything. And we do send out email alerts for disasters, space weather, stuff, and other things. We also do let our viewers know about our videos coming out, as we don't really trust certain video hosting platforms. You know who you are. Click posts to see the latest. Make sure you log in for your level. And if you are a gold level, you'll not only be able to see the plausible theory behind the mechanism underlying solar sunspot cycles, you'll be able to get your own at smashomash.com email address. Most first names not taken yet. smashomash.com/SmashTeam. We launched it to replace Patreon. It does have superior capabilities, and let's take a look at meteorology. So what we're looking at here is the lowest sea level pressure in the world. So here is the mean sea level pressure in hectopascals. There's the lowest pressure in the world, a huge low pressure here west of the Drake Passage. So only 952 hectopascals there. That is like hurricane scale low pressure. And I suspect it's probably pretty stormy seas around McMurdo Base and so on. Anyway, that's the current state of affairs of mean sea level pressure on a global scale. Let's close down that and just verify that there are no lower pressure zones. Again, that is a huge low pressure zone there. And indeed, that is the lowest pressure in the world, just west of the Drake Passage, which is a weird spot, folks, because it's where the Atlantic and Pacific Oceans need to reach static equilibrium. I mean, yeah, that's a lot of space, but that's a lot of water on either side of that space. So right now, water is likely rushing in this direction as we have high pressure on the east side of the Drake Passage and low pressure on the west side. Does that help? Yeah. The Earth, like the sun, it's trying to reach static equilibrium. All right, so let's continue on here to check out the wind situation. There are the surface winds of the eastern world. And there are the jet streams. No jet stream whatsoever around the equator here, around places like Papua New Guinea and Indonesia. Here are the jet streams of the western world. We have like a tripled up jet stream over North America there, and a huge divergence continuing in the eastern Atlantic. Here are the surface winds of this side of the planet. A triple low there in the North Atlantic, which means a triangle, which means the Illuminati is controlling the weather, which means HARP and chemtrails and all kinds of other non-existent things for people to leave ridiculous comments. We should make a video just about our BitChute comments because, man, if you want to see stupid comments, remember, folks, there are no stupid questions, but there are stupid people. And consumer tip, ignorance is the root of all knowledge. There's no harm in not knowing a thing. So those are the surface winds of the central world, Africa, Europe, and the Middle East. And these are the jet streams. Let's take a look at clouds and fog over the Americas. And it's certainly cloudy over the Lehigh Valley at the moment. By the way, if you're looking to go on a cycling vacation, join us here in Lehigh Valley, Pennsylvania. Trexlertown, Pennsylvania has one of the most substantial cycling communities in the whole world. And we've got some of the best cycling roads in the whole world as well. Also some fantastic mountain trails. So join us, perhaps do a ride with the Lehigh Wheelman Association. And let's move on to our weather.gov map. Blizzard warnings for most of North Dakota, large portions of Minnesota, and portions of Montana. On our weather.gov map, if your location's lit, click your location. Gale warnings up the east coast of the U.S. It looks like some great surf. Let us know if you've got a wetsuit. And if you're doing some wave hunting on the east coast. Again, lots of alerts there from weather.gov. Let's take a look at some forecasts. Here's your pressure and precipitation forecast based on the GFS model for the next 72 hours. 72-hour pressure and precipitation forecast. I won't explain it. It's on the screen for your viewing pleasure. We'll also show accumulated positive snow depth change in inches based on the same model. Some additional spots here in California expecting 2 to 3 more feet of snow. Also, all the hot air that's coming out of Colorado constantly is not enough to stop more snow from falling there. And the heaviest snows are expected, well, in eastern California, but also some heavy snows in Washington, North Dakota, Minnesota. I'll stop explaining now. That's a 72-hour GFS accumulated positive snow depth change in inches. Here's the difference between the Euro and the GFS model. That's the next 3 days of new snow based on the GFS model. There is the Euro model. Again, back to the GFS. That's new snow for the next 3 days. Euro model and the GFS. Next, NASA GOES lightning mapper showing us some huge lightning storms there off the coast of Florida, north of the Bahamas. Do we have any current terrestrial strikes? Doesn't look like it. Next time you hear thunder, check out the real-time lightning map from lightningmaps.org. Give that a minute to connect. And you can see the lightning is indeed continuing there in the southwestern Atlantic. We'll close out the video with Doppler, clouds and fog, and water vapor. So here's the U.S. Doppler. And there is currently a low that is, well, you'll be able to see it on the water vapor map. So let's just wait for that. Here's clouds and fog. And that low is located, looks like it's right over Long Island. Yeah, Long Island. Or maybe Connecticut, somewhere between Long Island and Connecticut, okay? So anyway, that's the water vapor map. Here's a recap. U.S. Doppler radar. Clouds and fog. That's 3.9 nanometer infrared radiation. Interactive weather goes satellite, by the way. And there is the water vapor map. Hopefully that clears things up. Thanks for tuning in to the channel. Congratulations on realizing it exists as we bring Earth weather and space weather together, citing fact after fact. We'll see you soon. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.